looks like. All right, so let's say you are given a graph, and now you have to graph that graph, and it's a piecewise function graph. So let's take a look at what that might look like. So let's say you're given f of x is equal to, and you're given one equation when x is less than or equal to 0. You're given another equation when x is bigger than 0, and we'll say to 2. And then we'll say something fairly easy for now. They'll say that f of x is equal to x when x is bigger than or equal to 2. All right, so let's look at these three values. So what you want to do, basically, there are three different functions sort of put onto one graph. And what you want to do is you want to identify the different parts of the graph. So x is less than or equal to 0 means that we pretty much have to say, okay, that's what it's going to be from here to here. So I'm only graphing to the left of the y-axis, just from here to here. This is the only part where I'm graphing right in there, because that's when x is less than or equal to 0, is when it's to the left of the y-axis. All right, so the graph is going to look like negative x. Well, we learned how to graph lines, and this is a line. This is basically the same thing as y is equal to negative x plus 0. So we have a slope of negative 1, and we have a y-intercept of 0. So that means it's going to cross the y-axis right at 0. And we're going to have a slope of negative 1. So a slope of negative 1 basically means that if I were to graph this, I would go to the right one and down one. So I would put my next point down here. The thing is, though, that I want everything to the left of the y-axis. So instead of going right one and down one, I'm going to go up one and left one. So like this. It's going to look something like that. And so I'm going to erase this because I only want the graph to the left of the y-axis. So then I graph that line. Oopsies. I graph that line. Looks something like that. Okay, and then I'm going to have a big filled-in circle at that spot. Now, the reason why I have a big filled-in circle is because, and I'll just go ahead and make this one green so we can kind of color code this a little bit, is because it says less than or equal to 0. So that means I include 0. All right, so now for my next graph, I'll make the next one blue. So I'm going to graph the line, and this is from 0 to 2, 0 to 2. That means I'm going to graph until 2. So this is 2 right here. So I'm going to cut it off. So it's going to be from here to here is where I'm going to graph. And I'm going to graph the line f of x is equal to 3, which is the same thing as saying y is equal to 3. Okay, so the graph y is equal to 3 is a graph where we're only interested in the y values of 3. Now, I need a little bit more space here, so let me kind of look at this over here. So y equals 3 is a line. It's a type of line that could follow the form of y equals mx plus b. But if it followed the form of y equals mx plus b, it would have a slope of 0 and a y-intercept of 3. So 0 slope means that you have 0 rise. So that means it's completely flat. And the y-intercept of 3 tells you it goes through 3, which is right here. Okay, so we know that it's going to go through 3. It's not going to have any rise, and so therefore it's going to be a completely flat line. So it looks something like this. But it only goes from 0 to 2. X value is 0 to 2, so that means it has to be cut off right here. It can't go any farther than that. All right, so the question is, do we include the endpoints? Do we include the 0? Do we include the 2? And if you look at it, because there's no line below the inequality, the answer is no, we don't include it. So that means we have to go back and erase that filled-in circle and do an open circle, and then another open circle here. Okay, because we don't include 0, we don't include 2. All right, so finally, we have the last one, which I will do in red. And the last one is everything to the right of 2. Everything to the right of 2. So that's going to be from here on. So this is going to be all the values to the right of 2 going that way. All right, so everything bigger than or equal to 2. And the equation is y equals x. Well, y equals x means that we have a slope of 1 and we have a y-intercept of 0. So it's the same thing as y equals 1x plus 0. So y-intercept of 0 and a slope of 1, so that means it would go through the origin, and then we get over 1 and up 1, and that would be a dot. Over 1 and up 1, that'd be a dot. Here's another dot, and it would look like this going up. The thing is, though, it's only defined starting at 2. So it looks something like this. Okay, and in fact, that is your graph. We typically show arrows to indicate that it would continue to go in both directions, but it would look something like that. So now a couple questions for you. First question, is this a function? Is this a function? And the answer is, does it meet the criteria for a function? For every input, is there exactly one output? And so a way to do that is to use your vertical line test. And if you look at the vertical line test, you can see that it would pass the vertical line test over here, because every time I draw a vertical line, it would only cross at one spot. And then right here, it gets weird. Right here, it gets weird. Does it cross at only one spot? Well, you might recall, well, my graph is far from perfect, but you might recall this is supposed to be an open circle. So therefore, if I draw a vertical line here, I'm not actually intersecting the graph in the blue one. I'm only intersecting the graph, the green one. So in fact, there is only one output for the one input of 0. The one output would be 0. Okay, so if I drew a vertical line right here on the y-axis, it only crosses the graph in one spot. And then, of course, anywhere where there's a blue line, it only crosses in one spot. Then it gets weird here again. But because this is an open circle on the blue one and a closed circle on the red one, again, you're only getting one output for that one input. So it passes the vertical line test. It is a function, and everywhere along there is a function. So the answer is, even though it looks weird, yes, it is a function. Okay, that is a function. So that's an example of a piecewise function. It has different values at different points. We just basically break it up into 3 different graphs, and we graph one graph for one set of x values, another graph for another set of x values, and a third graph for the third set of x values. All right, that seems like a good place to end. So actually, before we end, one more thing. What if I asked you to find certain function values? What if I asked you to find certain function values? So let's start by finding f of -2. Where would f of -2 be? So that means we have an input of -2. So you can look at your graph and say, okay, where's -2? Okay, here's the input -2. Where's my output? It's right there. But it's not obvious what the y value is there necessarily. So you come over here and you say, okay, which one of these things do I plug into it? Do I plug into that one? Do I plug into this one? Or do I plug into this one? But in order to figure out which one it is, you have to say, where does x equals -2? Where does it fall? Does it fall in this interval? Does it fall in this interval? Or does it fall in this interval? And we can see that -2 is less than 0, so it falls into this interval. So you're going to use that function. So to find f of -2, you're actually going to plug in to this one here. We're going to use f of x is equal to -x, because f of x is equal to -x when x is equal to -2. So you're plugging specifically into this first function. So we get f of -2 is going to equal +2, which makes sense because we can kind of see that over here. All right, so let's try another one. What if I said f of 3? Okay, we're not going to use this first one anymore because 3 is not less than 0. Instead, we're going to want to use this one. So x equals 3 fits into this third category. And so therefore, we're going to use the function f of x is equal to x. So f of x is equal to x is the function. So we just plug in for the input 3. And basically, it just is 3. f of 3 is equal to 3. Okay, and that kind of makes sense because you come over here to the graph, and you look at 3 and you say, I go up, where does the y value appear to hit? And it's 3. All right, so that's enough for today. Why don't you go ahead and write a summary in 2 to 3 sentences, describe what you learned today and what piecewise functions are all about. All righty, thank you very much.